Okay, welcome to part 2 of the experiment. In this case, we're going to be doing a clipper circuit. We're going to be designing a circuit that takes an AC waveform and chops off anything above 3 volts, just cuts it completely off. And so to do that, we have a resistor, diode, and a reference source. Let's do the reference source first. If this has a max of 3, this is 3 volts, and this is 0.7 volts, this must be set to 2.3 volts. So we're going to set this VREF using a DC meter to 2.3 volts. And then the next thing is to choose the resistor value. And the resistor value is going to be based on how much current we want to be able to pass through here. So to do that, let's just make a couple of assumptions. Let's say we'd like to have a maximum current coming out of the signal source as 10 milliamps. Let's assume that this thing can put out 10 milliamps, but we don't want to tax it any more than that. And let's say we have a maximum voltage of 10 volts. So we can choose the value of the resistor based on that current and that voltage. If this is at 3 volts, let's draw a little time sequence here. Let's say here's our triangle wave, 10 volts, and there's 3 volts right there. So at this instant in time right here, we've got 10 volts there and 3 volts there. We've got a 7 volt drop across that resistor. So we're going to say that for the resistor, voltage across the resistor is equal to 7 volts, 10 here minus 3 there, divided by 10 milliamps is equal to 700 ohms resistor. So we would choose a resistor of a 700 ohms to make sure we don't draw too much current out of the signal generator. And let's round that up to 1K. So let's round it up to 1 kilo ohm. Just because you can walk around and see them on the floor. 1K resistors are very common. So a 1K resistor will make sure we don't draw too much current out of our signal generator. You can go higher than that as long as you're not driving a heavy load. So what we'll do next is we'll go ahead and build this circuit, set the VREF. We're going to use just a plain old 1N4001 diode for this one here. It's a good general purpose diode. A 1K resistor there, and we're going to look at the output voltage here. And what we'll see again is regardless of the shape, frequency, or amplitude of VS, Vout is never allowed to go over 3 volts. And what we'll also do, we can also play with this DC voltage here and watch the clipping level move up and down as we change this voltage up and down. And remember, if you ever need to clamp the bottom of the waveform, you just flip the diode upside down. If you want to clamp to a negative voltage, you can just flip the polarity on your DC source. You can clip top or bottom at any voltage you like. So we'll go ahead and build the circuit and test it next. Okay, very good. So here we go. Part 2, we're going to be doing the clipper. And so what the clipper does is going to cut off the very top of a wave that we see. And so what we're going to start with is our series resistor, which was a 1K resistor here. So again, we're wiring our breadboard to AC, DC, and ground. AC is this lead here, so we're going to start with our 1K resistor. Let's bring that from there over to there. Okay, and I'm going to turn these voltages down before I build any further. Okay, and then we're going to go from there into our downward facing diode. I know that sounds like yoga. Downward facing diode. Like so. Okay, and then that's going to go to our DC supply, which is over here. And then from there, that's really about it. We just have to connect up our scope. So here's channel 1. The yellow probe is going to be on channel 1, which is going to be VS to the left side of the input resistor. And channel 2 is going to be on the output, which we're going to just grab onto the diode. It's a nice thick wire. It's easy to grab onto. And we can go ahead and see what we're doing. Right now, the voltage is set to 0, so we'll be clipping the top of the wave at 0.7. But then we'll set this to 4.3 and we'll see we'll be clipping the wave at 5. Now at this point, the scope is not happy because the wave is too small to trigger on. I'm going to set the channel 1 to be a little bit bigger, and then we'll set the trigger level there. So channel 1 holds still. And let's go back to a sine wave, like so. And then let's take a look at channel 2. And what we see is we already have a little bit of clipping on channel 2. Right now this is 0.5 volt per division. Let's make it way bigger. Let's go way bigger in amplitude. And turn the scope down. I know a lot of you like to use the auto set on the scope. To me, auto set is for amateurs. We only like to use it if we just don't know what to do. If you know what to do, it's always much more direct. So here we can see that the top of the wave is clipping at around 0.7. It's about 1/3 of a division. But let's bring this up to 4.3 over here. Okay, and what we should see is the scope clipping at 5 volts. Let's make the amplitude a little bit bigger and see if it really clips at 5. So right now this is 2 volts per division. Ground is right here. 1, 2.5 divisions. Sure enough, the wave is clipped off at 5 volts. And again, this clipper works for any amplitude. If the amplitude is too small, obviously it never reaches 5 and it won't clip. But any bigger than 5, it just keeps on clipping right there. If you change the frequency, slower, faster, it still clips. If you change the wave shape, if you go to a triangle wave, it's still clipping there. You can look closely and see a little bit of rise and fall right there on the scope. And that's because it's not a perfect 0.7 volt source. It has a little bit of forward resistance to it. And so it's not a perfect flat line there, but it's still pretty good. And then if we go to a square wave, a clipped square wave still looks like a square wave. But again, as you change the amplitude bigger and smaller, it still clips off at the same level here. If you change the offset, it still clips off at the same level there. So it's showing good clipping behavior. Okay.